Hi, and welcome to Maths with Corinne. This is the first sort of Thursday session that I've done. So the idea is that on Thursdays I don't deliver content as such, but I just go through any viewer questions and answers that you might have. So some people might have emailed through questions, or you can ask them as I go through, just like normal. So I've got 4 questions to go through with you this evening. They're all based around some of the content that I've covered in previous lessons, but obviously some other exam questions. Okay, so the first one, if I bring it up for you, is from a 2015 paper, and it's just asking us to simplify this fraction. So the first thing that we want to do is simplify that top line, because we can see that we've got some like terms there. So simplify that first, and then we'll see what sort of happens. So we've got 3ab squared minus 4a cubed b plus ab squared. So the 3ab squared plus ab squared gives us 4ab squared. We've still got our minus 4a cubed b, and we're dividing that by 4ab squared. Now you may be tempted to cancel these, but we know that we can't cancel those two terms because they're not factors at the moment. Okay, so this in particular is not a factor of that numerator. So what we need to do is factorize the numerator and then see what common factors we do have that we can cancel. So looking for common factors between our 4ab squared and our negative 4a cubed b. 4 is probably an obvious one. We've got an a in both terms, and we've got a b in both terms. So 4ab comes out in front. To get 4ab squared, we'd need to multiply that by b, and then to get negative 4a cubed b, we'd need to multiply that by negative a squared, and our denominator still hasn't changed. Okay, so this is already multiplying. We can already see our factors, and we've got 2 factors for the numerator. 4ab is 1, and that b squared minus 4ac. So we can cancel, because we've got 4 times a times b times this bracket, so we've actually got 1, 2, 3, 4 factors in that numerator, and 1, 2, 3 factors, although I guess you can count b squared as 2. So looking for our common factors, we can cancel the 4s, we can cancel the a, and we can cancel the b at the top with one of the b's at the bottom. So instead of being b squared, we just left b, which means our final answer is just b minus a squared all over b. That's fine, you can leave it like that. Some people will take this a little bit further, and if we think of this as being b divided by b minus a squared divided by b, that's exactly the same thing. We've just split the fraction up into 2, but obviously have the same denominator. B divided by b, we can simplify that to 1. So that would be 1 minus a squared over b. So this is an accepted answer, and this is also an accepted answer. So don't feel you need to go down to this. I would leave it like this. This one here. So for that question, as I said, it came from the 2015 paper. If you could simplify or factorize the numerator, you get achieved. And if you can get either this fraction here or this one here, then that was worth merit in that particular paper. The second question I've got is also from the 2015 paper. So we've got this fraction equals 3/4, and we are trying to solve. So what we want to do first with this question is actually try and factorize and see if we've got any common factors here. If we do, we're going to simplify that first, because that will reduce the need to simplify later on in that question. So this top one, x squared minus 1, it's got no common factors, but it's that difference of 2 squares that we've looked at in a couple of previous sessions. So we know that we can factorize that to x plus 1 and x minus 1. And on the bottom, we need 2 numbers that multiply to give us 1 and add to give us 2. So x plus 1 and x plus 1. And it's still equal to 3/4. We haven't changed that. Now we've got some common factors. We've got an x plus 1 and an x plus 1. So we can cancel those. And now we're just left with x minus 1 over x plus 1 is equal to 3/4. So in yesterday's session, we actually looked at a question sort of similar to this. So what we're going to do is we're going to bring our 4 across and multiply by the numerator on the left-hand side, and we're going to bring our x plus 1 across and multiply by the numerator on the right-hand side. And that way, we won't have fractions anymore, and we'll be able to solve it like a linear equation. So we get 4 times x minus 1 is equal to 3 times x plus 1. Okay, so remember when we have one fraction equals another, then we sort of multiply through, and we no longer have those fractions. So we can expand 4x minus 4 is equal to 3x plus 3. Collecting all our x terms on the left-hand side, so 4x, bringing our 3x across, we subtract it, so that would just give us x. 3, bringing our negative 4 across, we need to add it, so 3 plus 4 gives us 7. So we have one solution, x is equal to 7 for that question. Okay, so if you can factorize, then you can get achieved for this question. If you can simplify, so cancelling out those common factors, then that's merit. And if you get all the way through to x equals 7, then that's your excellent part for that question. Okay, so finding a single solution. This question, as it's written in the paper, I think actually had some working and gave you 2 solutions, and it was asking you to try and explain or show why there's only one solution. Okay, so that's one way that you can do that. The 2016 question. So it says a is equal to 3 times n squared minus 4n plus 2 plus n, and b is equal to 2n plus 1, all multiplied by n minus 6, plus n squared plus 3. Okay, so quite a lot of things going on here. The question is asking us to write a in terms of b only. So what that means is that we want to get a equals, and instead of having all of these n's, we just want to have a b. We may have some numbers that we're adding and subtracting to the end of that, so it won't necessarily just be b, but we don't want to have any n's, is really what that's trying to ask us to do. So the first thing would be to expand both a and b, and let's just see what happens. And from there, we might be able to find a way forward. So if we start with a, expanding out this, we get 3n squared minus 12n plus 6. And we've still got our plus n from the end here. And if we just tidy this up, we've got 3n squared minus 12n plus n gives us minus 11n. And we've still got our plus 6. So that's our a. We go this side and we expand out the b. So we've got 2n times n, which is 2n squared. 2n times negative 6, negative 12n. 1 times n, and 1 times negative 6, plus our n squared and our 3. And then tidying this up, 2n squared plus n squared is 3n squared. Negative 12n plus n is negative 11n. And then negative 6 plus 3 gives us negative 3. Okay, so b is equal to 3n squared minus 11n minus 3. A is equal to 3n squared minus 11n plus 6. So they look very similar. In fact, the only difference is the constant at the end. So we're wanting to write a in terms of b only. So that means we want a equals. If we write a equals b, we're close. We've got our 3n squared. We've got our minus 11n. We need positive 6. We've got negative 3. So with our b, so to get that up to positive 6, we need to add 9. And that's our solution. A is equal to b plus 9. We've written a in terms of b only. No more n, just b and a constant. Okay, so for this question, if you get all the way through and you get a equals b plus 9, and you've obviously shown your working and how you kind of got there, then that's excellent. For achieved, just jumping all over the show here, you correctly expand either A or B, okay, one or the other. And for merit, you correctly expand and simplify both A and B, or you write A in terms of B, but it's consistent with an incorrect expansion and simplification up here. Okay, so if, for example, you write plus 12 in here, and then follow that through, you'll get something different here. But if that happens, you can still get merit if you follow that all the way through. Awesome. And the last question for today's question and answer session, unless anyone writes another one quickly, from a 2017 paper. So it says, Jane thinks of a number, k. When Jane's number is cubed, the answer is m times k. When Jane's number is squared, it is n more than k plus 5. And the question is asking us to give an expression for n in terms of m only. So this is really similar to that last question that we just did. And we're dealing with n's and m's and k's in this particular question. And we also need to write out the equations that we're given from the context. Okay, so if we just go through those bits, when Jane's number is cubed, the answer is m times k. So when Jane's number, which is called k, is cubed, the answer is m times k. When Jane's number is squared, it is n more than k plus 5. So there's our k plus 5, and if it's n more, we need to add an n. Okay, so we know k cubed is equal to mk, and k squared is equal to k plus 5 plus n. So we want an expression for n in terms of m only. So we don't want to have any k's, we just want to have m's and n's. So the first thing I would probably do is rearrange this, because this is the only thing that's got an n in it. And so we want an expression to know what n is equal to. So we can use this to do that. So if we move both the k and the 5 to the left-hand side, we would get k squared minus k minus 5 is equal to n. Okay, so we need to see if we can figure out, instead of this k squared and this k, can we write that in terms of m? Now the only m we have is in this first expression that we wrote here, where k cubed is equal to m times k. So you'll notice you've got a common factor of k on both sides. So if we divide through by k, we have to do the same thing to both sides in order to get the equation to still be balanced, to still be equal. So k cubed divided by k is k squared, and mk divided by k is m. So from here, we know that k squared is actually equal to m, so we can already replace this. We know that that's going to be an m. We still have our minus 5, and we still have our n. We need to find k. We're going to use this to do that. If we know that k squared is equal to m, then we can undo the squaring in order to get k by itself. Okay, and to do that, we would take the square root. So when we take the square root of k squared, we're left with k, and we would then have the square root of m. So if k is equal to the square root of m, then in this expression here, instead of minus k, we're going to write minus the square root of m. So n is the same as m minus the square root of m minus 5. Okay, and that's our expression for n in terms of m only, plus that constant, just to balance that out. So for that question, it's another excellence question. Quite a lot going on there. So for achieved, you do one of the following. You can find that k squared is equal to m. So if you do that, that would give you achieved. Or you might find that your expression for k squared, or your expression here is consistent with what you found for k squared, even if it wasn't m. So if you make an error, again, there's that whole idea of consistency. Okay, or you might find that k squared is equal to k plus 5 plus n. That would give you achieved. Okay, for merit, you need to do 3 of those things. Okay, so finding k squared is equal to m, finding k squared is equal to k plus 5 plus n, finding a consistent expression for n, given that something's gone wrong somewhere, or writing, k equals the square root of m. That's the other thing you can do. Okay, so 3 of those 4 things would give you merit. Okay, and excellence is all the way through to this final step here. well, those were all of the questions that I had. If anyone has another question, if you've been working through any old exam papers or anything and you're not quite sure how to do something, feel free to email me. So my email address is up there. If you send it through, then I can go through it during a Thursday question and answer session, or you can just watch live and ask a question if you want to. It might be a little bit tricky to type some of the expressions that you might have in an algebra paper, so you might find it easier to email me. You can screenshot or just take a photo of the question and send it through if you like, and I'm more than happy to go through those with you during these Thursday sessions. If I just throw my timetable up. So next week on Monday, be the 24th of August, we're looking at solving quadratic equations. So I'll go through some examples, just talk you through that process, make sure we've got the skills sorted, and then I'll pull out some exam questions, probably from the 2019 and 2018 papers, and go through those with you and talk about how those questions are marked. And then on Wednesday next week, we're still looking at equations. We're going to look at exponential equations. So we'll again go through some examples, talk about the skill, how that works, and then go through some exam questions. For both of those, I will also talk about how you might solve those sorts of questions if you have an inequality as opposed to an equation. So that does come up sometimes as well. So that's what's coming up next week. So Monday 5:30 here, or Wednesday 5:30, and then once the live stream's finished, we'll pop up the link. You can watch it on YouTube. If you find this stuff helpful, please subscribe, like the page, and share it with others. It'd be really awesome to share it with as many people as possible, so that we can help as many people as possible. I know that this year's been a little bit unusual, so I want you guys to feel as prepared as possible for the assessment that you have coming up. Awesome. Well, thanks for being here today, and I hope to see some of you guys on Monday. Don't forget, email through any questions or send me a message. Happy to help you guys with those.